Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. If you know you have not subscribed, please subscribe, share to your colleagues. Please make sure that you like. Sometimes you get like 300 people, 400 people watching a video with 2 likes. You see, the more you like, the more my video or the YouTube picks my video and share it for me or move so that people can also watch. Okay, help me to get something out of what I believe. If not, buying markets and stuff is not easy. Okay, yes, thank you very much for doing that for me. Make sure you like, don't forget, just a click, you are good to go. Now we are going to look at even and odd function, and also when it's not even or odd, it becomes neither even nor odd, right? Yes, so that's what you are going to look at. So we first have, let me say this, I have this as my even and get something like this. Now when we say even function, what does it mean? Okay, so that one will be on this table. So for the even function, the function is said to be even if and only if f at negative x is equal to f at x. What are we trying to say? I will come back to that. Let's look at the odd functions. Oh, sorry. This place I will not write any proper thing though, and it has taken time, space like that. Odd function. So we said that are you seeing difference? Or I don't know whether you are seeing difference. This one, f at negative x, should also give us negative f at x. Okay, so let's look at some example, or let me give you an example first before I will explain it to you. So don't worry. This neither even number nor odd, I will come back to it. Examples. Okay, examples. You can have cos x. Okay, why cos x? Now look, if you look at the definition where we said that a function is said to be even if and only if f at negative x equals f at x. What we are trying to say is that if I take now my case study here, what I'm going to use these two numbers, 2 and negative 2. These two numbers is what I'm going to use here. So you can use any number of your choice, but remember, if you pick 3, then it should be 3 negative 3. If you pick 4, it should be 4 negative 4. It's not advisable to use 1. Sometimes 1 can behave like an identity, so it can do something to your function. So it's better start from 2, 3, 4 going. So I'm using 2 negative 2 to test something. Actually, we say that the function or this thing is f at negative x equals f at x. So the negative there will actually vanish from there. So we are saying that f at x equals cos x is even function. So let's test why we are saying that. So if I take f at negative, okay, let me start with positive 2. Positive 2, I'll get cos 2. Is that all right? If I take f at negative 2, I'll also get cos negative 2. But if you remember your trigonometry very well, remember, don't forget to cos negative 2 is the same as cos what? 2. Do you know that? You can use calculator and punch cos negative 2. The answer that you will get will be the same as cos 2. So in that effect, you can say that f at negative 2 is f at what? 2. Because f at 2, the answer that you get will be the same as f at what? cos negative 2 or cos negative 2. Is that okay? Yes. Let's look at the next example. X to the power, let me use I'm doing some things here, I don't understand. This is with this, this is with this. Let's also look at this example, x to the power n, where this n is what? Even numbers, okay? So we are saying that x to the power n are all even numbers. When when n is what? Even numbers are all sorry, even function. So means that x to the power 2, x to the power 4, x to the power 6, going. So we can get x to the power 8, x to the power, you can count it. So let's test and see. Let's say if I have f at x is equals to x to the power 2. Okay. Now, if I take f, now I'm saying I'm using this as my case state. So x to be negative 2 here. It means that wherever I see this, I'm going to put negative 2 there. So I'm going to have negative 2 squared, which is 4. Do you agree? Yes, sir. I have responded myself. Then I take f at 2, which will also give us 2 then squared, which also give you 4. So if you look at this, then you can conclude that f at negative 2 is equals to f at what? 2. Therefore, this function is what? Even function. Is that okay? Yes. So we are saying that all x to the power n, where n is even number, then you can conclude that those type of functions will be what? Even function. Now you could see that what I had here is the same as what I have here. This is 4, this is 4. When you compute some function, let's say this place is 4, but here is 3, you cannot call it even function. The number must be the same, and the sign in front of them must also be the same before you can conclude. I hope I'm clear. Yes, I am clear. Thank you. Now, let's move on to the next one, or the next example. We can also have C, where C is what? Constant, okay? Where C is constant. So let's see. Why are we saying that when C is constant? When C is constant in the sense that, let's say if I have f at x equals 1, we are saying that 1, 1 is a constant, 2 is a constant, 3 is a constant. 1 here, this one is even function. Don't get me wrong. Don't go and stand somewhere and say that I said that 1 is even. No. Here we are talking about even functions. There's difference between function and numbers. If I said odd numbers or even numbers, is different from what? Even functions and what? Odd functions. So this is a function. So if you say that constants are even functions, what you are trying to say is that if I'm taking the 2 and the negative 2 as my case study, look, if I have f at negative 2 of this one, this will still be 1 because this one there's no x attached to it, so there won't be any effects on it. Do you understand that? Now, if I also have f at positive 2, it's also 1. Therefore, we can say that f at negative 2 is equal to f at what? Positive 2. So this one too works. Perfect. Now, let's move on to, so that's all the examples that I have. Okay, that's all the example. You can look for your examples and try to solve, but I will give you, or I will come and solve examples to you, but I want to explain the even functions. Now let's move to the odd functions. For now, the odd function, we are saying that a function is said to be odd function if and only if this holds: f at negative x is equal to negative f at x. If this one holds, then you are good to go. Now let's look at something here, some examples. First one, sine x is first candidate for odd functions. Yes, because if I take f at x to be equal to sine x, Then what I'm trying to do here, one, if I take f at, let's say, -2, what am I going to get? I'm going to have sine -2, right? Good. But if you remember your trick very well, this is the same as negative sine what? 2. Is that okay? If I take f at +2, I'm going to have sine what? 2. What it means is that f at -2 is going to be, now look, it's going to be negative f at what? 2. Why am I saying this? If you look at the first one, f at -2 here, we have negative sine 2, and f at 2 is sine 2. So in place of this sine 2, can I put f at 2 there? Yes. So when I come back here, in place of this sine 2, if I put f at 2 there, then it will give me this. So this is what? Odd function. You can also have another example. Yes, perfect. Another example is x to the power n, where this n is what? Odd numbers. So x to the power n equals, where this one is odd numbers. So we can have n to be 1, 3, 5, and so forth. So example is, if I have f at x equals x to the power, let's say 3, what do? F at -2. This is going to give us -2 to the power 3, which is -8, right? F at +2 is 2 to the power 3, which is what? 8. You can see -8, +8. So therefore, f at -2 is equals to -f at what? 2. So this is how we prove it. So please make sure, as I said, make sure that the numbers are the same, but for the odd is opposite to each other. The even, the numbers are the same, and their sign, the basic operation sign, that's the minus or the positive, the negative or the positive, should be the same for the even, but for the odd should be what? Opposite to each other. This is negative, this is positive, but the numbers are what? The same. But if here is 8, -8, and here is +7, then you cannot call it odd. Is that okay? Yes, you cannot call it odd. So when we have a case like that, when it is not odd, neither even, then how do you call it? You just say that the function is what? Neither odd nor what? Even. That's all. So let me proceed again with examples. Now let's look at the examples, okay? So I have my examples here, show that whether the functions are odd, even, or neither even nor odd. Okay, so we have first one, f at x equals x squared plus cos 2x. How do you show that? So let's see. First one is f at x equals x squared plus cos 2x. Okay, so now I'm going to choose these numbers. -2, 2. Okay, these are the numbers I'm going to use. So if I take f at, let's say, -2 first, that's going to be -2 squared plus cos 2 multiplied by -2. Okay, so that's what you're going to get. So f at -2, if you do it very well, you are going to get 4.998. Is that okay? Then you also pick f at +2, which is going to be 2 squared plus cos 2 times 2. So we have f at 2, which was going to be 4.998. So you conclude, therefore, since f at -2 is equal to f at 2, the function is what? Even. Is that okay? Yes, so that's how you go about it. Now let's look at the second one. F at x equals cot x. Okay, now let's look at this one. The second example. f at x equals cot x. So still we are using, I'm choosing my numbers to be negative 2, 2. Is that okay? So here I can say that f at negative 2 is equals to cot negative 2. Is that okay? So f at negative 2 will be cot negative 2 going to be negative 0.4577. Then f at positive 2 will be cot 2, which is going to be negative, sorry, f at 2 is going to be positive 0.4577. Now, once you can see this, you see this and that are the same by the sign that makes it opposite. So we can conclude that since f at negative 2 is giving us negative f at 2, then f at x equals cot of x is odd function. Is that okay? Good. Now I am going to leave this one for you to try so that we can do this one, the last one. So I'm going to leave this one for you to try. Okay, so let me clean this side and do the last one there. We have f at x equals x squared plus x cubed. So my testing numbers are negative 2 and positive 2. So first, f at negative 2, what are we going to get? You're going to have negative 2 squared plus negative 3 cubed. So f at negative 2 is, now negative 2 squared is 4. Negative 3 cubed is negative what? 8. So this is going to provide this answer, negative what? 4. Is that right? Yes. Now we move to f at 2, which is 2 squared plus 3, sorry, 2 cubed. I nearly interchanged the power and that of the base. So here f at 2, 2 squared is 4 plus 8, which is 12. Okay. Now, if you look at this one very well, you realize that the f at 2 and f at negative 2, the numbers are not the same. Please, here again, we are not just using the sign. Aside the sign, you look at the numbers. Here, the numbers are not the same. Here is f at 2. Here is f at negative 2. But here is negative 4. Here is positive 12. Though the signs are opposite, which can make it odd, but the numbers are not the same. So when it happens like that, you state that since f at negative x is not equal to negative f at x, then the function which is f at x equals x squared plus x cubed, okay, is neither odd nor even. Is that right? Because this one cannot be concluded as what? Even. If you do that, they can call you to the court of what? Mathematics to answer some questions. Is that okay? So good. So we are done with this. I hope from now onwards, anytime you see a question like this, to show whether it's even or odd or neither even nor odd, you can easily do it. Good. Now, let's move to the next topic. Thank you very much for watching.